Hello students, today we will solve the question number 3 and the question goes like this. Figures below show the field lines of a positive and negative point charges respectively. Both the charges are point charges, one is positive and other one is negative. We know that for positive charge, electric field lines move outward, radially outward. The other thing we know is that for a negative point charge, electric fields are radially inward. So see over here, for this positive charge, the lines are going out. The arrow is showing outside. And for this particular charge, lines are going towards the negative charge. One thing which we know is that electric field lines show the how powerful the charge is. More the electric field lines, more is the magnitude of the charge. So here near the charge electric fields are denser. Near the charge electric fields are denser. So they have more effect over here than at this particular point. Then we are given here 2 points in the diagram. These 2 points are point P and point Q, point A and point B. Point P, point Q, point A, point B. One thing which we should write over here for our clear understanding, distance of P is lesser than distance of Q from charge, from positive Q charge, and distance of A is lesser than distance of B from negative Q charge. Now this plus Q and minus Q is not given in the question. We have taken these as the point charges. Point charges. This is the description of the question. This is the the values, the system of the given question. Now here is the questions they have asked us. There are like 5 subset of the questions which they have asked. We need to, in first case, we need to find potential difference. Potential difference. Just a minute. We need to find potential difference. V to Q, B to A. Okay. See, one more thing which I want to make clear in the initial step is that the potential at P is greater than potential at Q. Similarly, potential at A is greater than potential at B. Here, this potential is given as KQ by R. Okay, this Q is positive. For this, it is given as KQ by R dash. Q is positive. So, VP, VQ are positive. But in this case, the potential is given by the same case, but our Q is negative. As our Q is negative, VA and VB both are negative. Both are negative because the sign of potential depends upon the charge under the consideration. Okay. So in the first we need to find potential difference. Only potential difference. Now in the B, give the sign of the potential energy difference of a small negative charge between the point Q, P and A, B. we are bringing a very small q charge, which is negative q charge, negative q charge between P and Q and A and B, and then we are trying to find the potential energy difference. In the third subset, they have asked us give the sign of the work done by the field. In the third, we are asked to give the sign for the work done by the field in moving a small positive charge from Q to P. In this case, figure 1, in figure 1, we are moving some plus Q dash in the field and we need to find the work done. In the in the D subset, we need to give the sign of the work done by an external agency in moving a small negative charge from B to A. D subset relates to figure B. And the last subset of the question asks us, does the kinetic energy of small negative charge increases or decreases in going from B to A when we are bringing our small negative charge in figure B from B to A, from the outer point to the inside point. What is the condition for the kinetic energy? Is it increasing or is it decreasing? So these are the 5 things we need to find with respective to the given data. In the given data, we have a positive and a negative charge which are giving us some electric field lines. Hence, they will produce some potential, some force on any charge when brought in the vicinity of these positive and negative charge. What kind of charge we are bringing? We are bringing a small positive charge in the figure A and small negative charge in the figure B to find the work done, and to find the potential energy difference we are bringing a negative charge in the vicinity of both the positive as well as the negative given charges. Okay, so now we will proceed to the solution. How we are attempting to solve it is that the potential differences Vp minus Vq we have to give. As V is proportional to R, we know that potential is given as K Q upon R, where K is given by 1 by 4 pi epsilon naught, which is a constant. So V is proportional to 1 by R. If R increases, V will decrease. In case of VQ, V at Q, R is bigger than the R for the P. Hence, our potential will be greater for the point P than the point Q. Therefore, bigger potential minus the smaller potential will give some value which is bigger than 0. Hence, we will have it as a positive potential difference. V minus Q will give us positive potential. Secondly, V minus B, like VB, V minus VA. We have to find potential for it. Both are negative. See, this is our negative charge. And these are the fields which come to the negative charge because they are inward, radially inward. So in this case, we have to find our A is here, our B is here. Distance of A is smaller than the distance of B. Hence, what will come? VA will be greater than VB. If we assume that this is 6 volt, minus 6, because this is minus, so the potential will be minus, the magnitude of these will be in negative, and this will be 3. Here the numeral value is smaller, but because of sign this value is becoming bigger, because of introduction of sign. VB is greater than VA. So minus 6 minus of minus 3, right? If we are bringing, then there will be some differences over here. So both are negative in such case. Our B is bigger when this is subtracted, minus of this, minus of minus 6. We are not going VA minus VV. This is not what we are going to find. We will find this potential at B minus potential at A. Potential at B minus potential at A. So we are taking a numeral value for a better understanding, that potential at A is given by this and B is given by this. So this will come minus 3 plus 6, and we will get an answer as plus 3. So when potential at B minus potential at A is found out, we found that the value is greater than 0. Hence the value is positive in nature. So we conclude that Vp minus Vq and Vb minus Va are positive. Difference is positive, sign is positive. Now next was potential energy difference. Our first was potential energy difference. Next is potential energy difference. What was first? Potential difference. First was potential difference. Next is potential energy difference. See, this is our positive charge. We brought a negative test charge or negative small charge. Negative small charge in the vicinity of our plus charge. We will see a force of attraction. Similarly, we are having a negative charge. We brought a negative test charge. We brought a negative test charge in the vicinity of our negative charge, and we will feel a force of repulsion. We will feel a force of repulsion. It is on the loss of charges, which states that like charges repel and unlike charges attract. Okay, so what about the points? Point P is over here. If we assume it's not VP, it's simply point P is here, Q is over here, point A is if here, point B is far. Distance we will write in the terms of distance. See over here, RP is a smaller distance when compared with RQ. RA is a smaller distance when compared to RB. Okay, farther points are Q and B, nearer points are P and A. Okay, now voltage, this potential at Q and potential at P. If we find potential at Q will be lesser than the potential at P, similar the last concept which we have used, and energy is given by the potential differences. Energy is given by the potential differences. So potential energy difference will be positive, as we have found out in the previous subset 1. Now when we see this one, BA is smaller than BV is smaller than VA. Hence, when we are subtracting the two values, we will get a answer which is positive. The same rule of this, which I have explained for the potential difference, also applies here. The magnitude is smaller, but as we are introducing a sign of negative, because we are feeling a force of repulsion, the potential at B is greater. It becomes greater than potential at A. Now the third one, sign for work done. Sign for work done. The condition over here for commencing the work is given as our charge is a positive charge. We have taken a positive charge. That charge is moving from point Q to point P. Positive charge is moving from point Q to point P, and it is going near to this positive charge again. Okay. So here the charge is brought from the lower potential to the higher potential. As we will go positive charge, as it will go more near to the same positive charge, what will happen? They will start repelling each other. So it is very much tough for us to hold our test positive charge near the original positive charge, because both are positive. They will show the repulsion. So we will say that it is brought from this lower potential to higher potential, and when we are bringing from lower to higher, the repulsion will increase, and we need more external force to keep it in the position. Should be applied. Why? Because we know that force, work done is given by force into the displacement. Therefore, work done by the electric field is in the opposite direction of external force, and hence it will be negative in nature. How come? See, when we are bringing this particular charge near the positive charge, we need to apply the external force. Electric field force will try to repel but with the force of external, like external forces, what we are trying to do, we are trying to bring these two charges together. So we need to apply more force. Our force external should be greater than electric field force to make any movement. If it is lower, then it will start retracting. It will go backward. To make it move forward, external force should be greater. So the direction of work done by the electric field force is negative. It is working against the motion of positive test charge. Working against the motion of positive test charge. Write the statement: working against the motion of positive test Q charge. Okay. Now D subset, motion of small negative charge from B to A. From B to A. From here to here we are moving. Okay. And what sort of charge we are having? We are having a negative charge. And here they are asking us what is the sign for the external agency. Here also the concept is that potential at A is greater than potential at B with respect to the magnitude, and with respect to the sign. When we are taking the sign consideration, potential of B becomes greater than the potential of A, and when we are moving from here to here, our electric field force due to electric field is in the negative direction, will oppose the motion, whereas force external will support the motion and will allow our test charge, to move forward, move near this negative charge, So in that case, our sign for the external force and work done with respect to the external force will be positive. Work done with respect to external force is positive. And the last subset asks us the kinetic energy of a small negative charge. Due to the forces of repulsion on the negative charge, the velocity decreases. Hence, the kinetic energy decreases from going from B to A. Our negative charge is kept here, point A is here, point B is here. What is happening? Charge is going from here to here. Okay, so this is our negative small charge. When this is going here, force of repulsion increasing. Force of repulsion increases. As force of repulsion increases, our velocity, the motion, is decreasing. We are applying the same external force. Same external force is applied throughout the journey of understanding the effect of kinetic energy. Same is applied. So when the same is applied, force of repulsion is increasing, velocity is decreasing. Our kinetic energy is given by half mv square. So kinetic energy, in case of other factors when they are constant, we are taking the mass of our small q charge to be constant only, it is not fluctuating. So only thing which can affect our kinetic energy is the motion, the speed, the velocity. Okay, so kinetic energy is proportional to the velocity. As the velocity is increasing, our kinetic energy will also increase. As the velocity is decreasing, our kinetic energy will also decrease while moving from B to A, or we can say from far point to near point. From far point to near point. So these are the 5 subsets of the question number 3 which we have done. I hope you understand how to find the potential difference, potential energy difference in work done, and what is the relation of kinetic energy to. So these energies, and understanding how these energies are dependent on each other, on other various factors like the distance, velocity, and the electric field, external or the internal forces. One should be very much aware of the definition of potential difference and potential energy difference, how these two values differ from each other, from which our work done is found out, like which is the direct formula. Is it the potential or the potential energy which gives us the work done? Work done is force into the displacement, and it is related to the energy used up. So for all these basic definitions, one should refer to the previous class notes. And the other thing, once you know the definition, you should know the relation between distance, velocity, external force, or the electric field force. These are called internal forces from the charges itself. One should be very much careful when they are reading the charge, whether the charge have what sort of magnitude, a smaller magnitude or a bigger magnitude, what sort of sign they are having, is it a negative charge or a positive charge. They should be made a proper given statement. Like in many questions, I prefer giving a statement like in the question we have given information like the magnitude of charge, the sign of charge, the distance between the charges and all. Make one rough sheet about it, like when you are dealing with this one in a paper, there is this question written over here. First thing you should write is given information or provided information in the So in the question, so right, charge is given this, external force is this, distance between the given charges is this, how many charges do we have, and then what value do we need to find. These are the things we need to find. So we will have a clear cut information what all we are having and what we need to find out. Then after doing that, we need to know what is the formula used and what are the other relations. So once you understand this kind of concept based question will be easier to do. This question is purely based on the concept, how you understand it, how you know the relation. If one relation is wrong, whole answer will be wrong, because on the potential difference depends our potential energy difference. On the potential energy depends our work done, and to understand work done we should have a understanding of external forces also, and then the kinetic energy, which is also one of the part of work done, and the potential energy. So that's all for today's class. We'll meet up in the next class with a new question or new concept. Okay, take care everyone. Bye bye. Have a good day.